बोलिए मैडम।
Good morning, all. Am I audible? Am I audible, Chetan sir?
Yes, madam.
Am I audible? You are also
Yes, yes,
audible.
you're audible. I am making you host.
Okay, sir.
Madam, you are host already.
Sir, which one is mine, sir? One is host and one is co-host. I have also joined from AI department.
Madam, 1 minute. Yes,
Hello.
you are already host, madam.
Okay, sir. Hello.
Yes.
Sir, can you please log in with then Chetan Dule so that there will be no confusion, sir, if there are two AI departments.
Yes, yes. Just a minute. I am leaving the meeting and I will log in with my ID.
Okay, sir. Hello, good morning all. Prasna sir. Good morning, Prasna sir. Are you there, sir? Prasna sir, I've given you the presenter rights, sir. You can share your screen. I welcome you all again. And on behalf of AI Department, GHRIT, and Cloud Computing Center of Excellence, GHRC, I welcome you all to the third day of this FDP. Today's session will be conducted by Unisoft Technology, Mr. Prasna sir. Over to you, sir. You can start.
Thank you, ma'am. Good morning, everyone. Hello. Good morning, everyone. So today we are starting with the new session with the topic VPC, that is Virtual Private Cloud. I'm audible. Hello. Am I audible to all of you? Hello. Yes. Okay. So starting with the new session, that is VPC. This stands for Virtual Private Cloud. VPC is nothing but the Amazon Virtual Private Cloud, which provides the logically isolated area of AWS cloud, where you can launch AWS resources in virtual network that you define. It means the virtual network where you can create your own IP addresses CIDR, and you can run your instances in that IP address region. Okay, you have complete control over your virtual networking environment, including a selection of your IP address range, the creation of subnets, and the configuration of route tables and network gateways. These all things are necessary for the creation of VPC, that is Virtual Private Cloud. Subnets are nothing but the availability zone. As I told you yesterday, every region has some numbers of availability zones. So subnet is nothing but the availability zone of your VPC, and the configuration of route tables. In route tables, we just give the paths to the instances according to their availability zones and their IPs. And network gateways are nothing but the internet gateways and peering connection gateways by which you can connect to internet. You can easily customize the network configuration of your own Amazon private cloud. You can provide multiple layer of security, including security groups and network access control list to help control access to Amazon EC2 instance in its subnets. For example, you can create a public facing subnet for web servers that can access to the internet, and can also place your backend system such as database or application servers to a private facing subnet. Means from one subnet you can connect to internet, and from another subnet you can connect to your internet of internal organization without internet. Okay. So now, as you can see, there is a image on the display. There is a VPC with public and private subnets. Here you can see the outer wall, the basic architecture of a VPC, where you can see the public subnet instance, private subnet with the instance. Every instance has its security group. Security group is nothing but the ports allowed, like a firewall, ports allowed for the internet connection, network ACL, router table, and the main router table. Every VPC has their VPC has their internet gateway and security group. Here in the image, you can see the outer line represent the region, and the region is US East 1. The outer line, I'll show you just the outer line that shown in the image. Inside the region we have VPC, and outside the VPC we have internet gateway and virtual private gateway. Inside the region we have VPC, we have internet gateway and virtual private gateway. Both these connections, internet gateway and virtual private gateway, are the ways of connecting to the VPC. Both these connections go to router in VPC, and then router directs the traffic to route table. The traffic will be of incoming or outgoing. Route table will then direct the traffic to network ACL, and network ACL is the firewall, or much like security groups. You can see the router transmit the connection to the router table and then network ACL. Now, moreover, the security group, the accesses another line against the EC2 instance. It has two subnets. After the network ACL, you can see there is two subnets. One is public and one is private. Okay. In public subnet, the internet accessible by EC2 instance, but in private subnet, an EC2 instance cannot access the internet on their own. We can connect the instances to connect an instance moreover to the public subnet, and then it access to the private subnet. This is known as jump boxes. In this way, we can connect an instance's public subnet to instance with private subnet. That connection of jump boxes is called NAT gateway. That is the connection provided to private subnet by public subnet. There are some ranges for the private subnets, which are 10.0.0.0, 172.31.0.0, and 192.168.0.0. Whenever you create your AWS console ID, there is always one VPC, one security group, and a registered private subnet ID. Most of the time, the IDs are 172.31.0.0. Now, what can we do with VPCs? Okay, to launch instance in a subnet of your choosing, we can choose our own subnet addressing. We can assign custom IP ranges in each subnets. We can configure route tables between the subnets. We can create an internet gateway and attach it to our VPC. It provides much better security control over your AWS resources. We can assign security group to individual instances. We can also have the subnet network access control list, that is ACL. The main components of VPC are CIDR and IP address for subnets, implied router and routing table, internet gateway, security group, network ACL, virtual private gateway, peering connection, and elastical. Going ahead, virtual private cloud, Amazon Virtual Private Cloud, Amazon VPC enables you to launch AWS resource into a virtual network that you have defined. This virtual network closely resembles a traditional network that you had operated in your own data center with the benefits using the scalable infrastructure of AWS. Talking about the VPC more, VPC is a virtual network or a data center inside for one client. Inside one client, it has a logically isolated from other virtual network in AWS cloud as it is customized. Maximum 5 can be created in 200 subnets in one VPC. In an account, maximum 5 VPCs can be created at a time, and 200 subnets can be created in one VPC. We can allocate maximum 5 elastic IP in each VPC. We can create VPC, DHCP, NSCL, and security group will be automatically created. Once we had created a VPC, the another networking like DHCP, NSCL, security group will be automatically created. A VPC is confined to an AWS region and does not extend between the regions. It has confined region, it does not cross its region automatically. Once the VPC is created, you cannot change the CIDR block range of that VPC. If you have the different CIDR size, create a new VPC. You cannot change the CIDR size. The different subnet within the VPC cannot overlap. You can, however, expand your VPC CIDR by adding new extra IP address ranges. First of all, I will like to show you how the previously configured VPC looks like. As you can see, this is my console. I'm showing you if it is not. Okay, now as you can see, this is the AWS console. Okay, here when I search for VPC, that is isolated cloud resources. Here you can see I am in Mumbai region. In this region, I am having a VPC, and each region have one VPC by default at the time of creation of account. Each region has a number of subnets according to their availability zones. Some of having 4, 6. North Virginia is the very first region to introduce AWS, and it has the highest number of availability zones. Route tables. This is the table where you can route your traffic between your subnets by giving them the proper connections. Internet gateway is provided for connecting you to the internets, and all of these other things that DHCP set, network ACL, security groups is previously created groups. These previously created automated things. When you create your ID, one default subnet and default VPC ID is generated. Okay. As you can see here in security groups, I'm having some security groups where one is default, which is made at the time of creation. It is having 4 permission entries which are customized by me. Okay. So if I create VPC instance, if I create VPC instance in this given default VPC. EC2 instance in this reason default VPC. I will just launch. Okay, I'll just launch an instance from here. Launch instance. Giving some name. Launching an Amazon Linux instance with AMI. Selecting keypad previously created. Here you can see there is a default VPC setting in networks with no subnet preferences, auto assign public IP enabled. Okay, I'm checking this checkbox for internet connection for HTTP and HTTPS and SSH traffic from. I'm creating a separate security group for my instance. I can choose existing also, but I want a new one. That's why I will use this option, create security group, and launch. I will launch my instance. You can see the instance is starting. It's in a running state, and the status check is initializing. Till the time we get 2x2 check. Yes, I'm creating a virtual machine which is based on given default VPC. After this, I will show you how we create a customized VPC and how will we launch the customized instances on that VPC. And how to connect private VPC with the help of private instance with the help of public instance in that customized VPC. Okay. Till the time it's get 2x2 check initialization status check. We'll just go for its details. Here you can see we have a public IP, a private IP. Here, as I said, there is a custom, some reserved IP ranges, that is 10.0.0.0, 172.31.0. So here in our AWS console ID, there is a private IP subnet ranges is reserved, that is 172.31.0.0, and the two subnet mask blocks were open, so they got 39.191 private IP right now. Okay. Now I will connect it. Here in local user, I will be first come in root user, that will be command sudo hyphen Then if I run IPAS command, so it will show my IP, that is 170.31.191, that is my private IP. Here my CIDR is fixed, that is 172.31. This is the range. Okay. Though I am connected from my public IP, but the CIDR range is fixed because of my default VPC. Okay. If I create a custom VPC, then my private IP will be according to that custom VPC, which I will be given to my VPC. Okay. As I have allotted the HTTP ports, so I will just install some configuration, connect my server to internet, to host my things on internet. Okay, I will create an HTML file inside it. Whatever. It's actively running. Now I will copy my public IP of instance of my instance and paste it on a browser. Where I can see the configuration of my HTML file on my EC2 instance, which I have created just to show how to connect the instances up. Now, again heading towards back towards our VPC console. I'll just so we have just seen the default VPC default instance creation with using default VPC and security groups. Now, in this VPC types, we have default and custom VPC. In default VPC, it is created in AWS region when an AWS account is created. It has a default CIDR security group, NSCL, and route table setting. Has an internet gateway by default. In custom VPC, a VPC on AWS account that owner creates by own. Creator can decide the CIDRs. It has its own security group, NSCL, and route table. It does not have an internet gateway by default. One needs to be created if needed. If you want to connect your instances made on your custom VPC, then you have to create internet gateway. Okay. Now there is subnets. We have two kind of subnets, that is public subnet and private subnet. If public subnet traffic is good, in public subnet, if subnet traffic is routed to an internet gateway, the subnet is known as public subnet. If it is connecting to internet gateway, then it's known as public subnet. If you want your instance in a public subnet to communicate with the internet over IPv4 address, it must have the public IPv4 addresses or an elastic IP addresses. Okay. If you want to connect your instance with the internet, you must have the public IP. In private subnet, if subnet does not have a route to the internet gateway, subnet is known as private subnet. It means if your instances don't know the route for the internet gateway, it means it is a private subnet. When you create a VPC, you must specify on IPv4 CIDR blocks for the VPC. The allowed block size is between /16 to 28 net mask. The first four and the last IP address of subnet cannot be assigned. Now, there is an implied route and route table. I'll show you the subnets. Okay. Here we are having option of subnets. Here we can create subnet of our own choice in our own VPC. Right now we are having only default VPC, not custom VPC. So we will create it later by using our default custom VPC. Now, implied route and route table. It is the central routing function. It connects the different availability zones together and connect the VPC to the internet. You can have up to 200 route table per VPC. As we can create 200 subnets, it means we can create 200 route tables each for the subnet. Each one for each subnet. Each subnet must have be associated with one route table at any given time. You can have up to 50 route entries per route table. Each subnet must be associated with the one route table at any given time. If you do not specify a subnet to route table association, the subnet will be associated with the default VPC route table. You can also edit the main route table if you need, but you cannot delete the main route table. However, you can make a custom route table manually become the main route table, then you can delete the former main as it is no longer the main route. You can associate multiple subnet within the same route table. Now, I'll tell you how to create a custom VPC. First, we'll come in services, that is VPC. Search for VPC and select the first one, VPC isolated cloud resource. There might be available for default route table, but when you are connecting the custom VPC and different subnets, then you have to create the route table for that customize VPC and subnets. It will be easy to help you to find out which route table is there to connect your VPC and instances. If you need to delete it, you can delete it easily. Create VPC. Here we will choose VPC only. I am putting the name VPC is that VPC1. Putting the manual CIDR input, as I am having the VPC default which has the manual CIDR 172.31. Now I am creating a custom VPC, so I will be putting according to myself a reserved CIDR IP that is 10.0.0.0. Here we can see the net mask is reserved. The reserved net mask is 8. But I want to reserve the first two net masks, so it will be like 16 for the IPv4 CIDR. I'm not giving any kind of IPv6 CIDR. The tendency is default and creating the VPC. As you can see, the VPC is created, but it does not have any kind of it does not contain any kind of subnet or route table or internet gateway or any kind of connection in this. So as we have seen the subnet description, we will create subnets from here. Subnets, create subnet. After creating subnet, we will select this here. First, when we have seen before, then that time there is only one default VPC showing. Now there is one more VPC which we have created with our CIDR 10.0.0.16, and the previous one is having 172.13.0.0/16. So we will be selecting our new customized VPC, VPC1. After selecting, it is showing its CIDR and it's open for creating subnet. When you will be creating the another VPC, that time if you are using the same CIDR, it will not create your VPC ID. That it will say that it's overlapping with the another VPC CIDR. Even though when you are creating subnets, if your subnet range CIDR is overlapping, then also your subnet will not be created. So I am giving subnet name, the public subnet. Availability zone, I am selecting AP South 1A. IPv4 CIDR block, that means what will be the range of your CIDR, subnet CIDR. So if my VPC is starting from 10.0, then my subnet will be start from 10.0 as well. And here I am reserving the third net mask by using 1 or 0. With the number we can go up to 255. Okay, then 0, then /24. Here I have reserved the third net mask for my subnet. Okay, now I create a subnet. Here you can see I have created a subnet, public subnet. Okay, after creating public subnet, we'll go to instances and launch VPC. Launch instances using our customized VPC. So I have the first server named instance. We'll create another instance using custom VPC. So I will select launch instance. I'll be giving the name public instance. Not get confused. Like in the previous key pair, I can use the Amazon key pair again. Now here I'm allowing the HTTP and HTTPS ports because I have created the public subnet and I want to connect it to internet. So now, but I have created the custom VPC, so I will change the default network VPC with my custom. I'll go into the edit, select VPC1 in place of default, and as I have created only one subnet, so there is only one option showing, that is public subnet. Here you can see the auto assign public IP is disabled. It means it will, if I put if I launch the instance, it will create a private instance, but I want to create public instance, so I will enable it from here. So it will assign a public IP to my instance and launch the instance. Okay, in instances, we can see a public instance which is made on our custom VPC is creating, and in details you can see its private IP addresses is from the CIDR range we have given in our CIDR, that is 10.0.1. we have given into subnets .247. We'll just check it's 2x2 check. Is it available or not? It's initializing. We will wait for 2x2 check. Still initializing. We'll wait for time. Initialize it. Okay, now it's we have 2x2 check pass. So I will try to connect this instance. So you can see this failed to connect your instance as EC2 instance connect is unable to connect your instance. Ensure your instance network settings are configured correctly for EC2 instance connect. For more information, see the setup EC2 instance connect at the link given below. Okay, so this has happened because we have not given internet gateway to our instance yet. So we will create internet gateway from our VPC console. I'll just create internet gateway. That will be like IGW1 internet gateway 1. Create internet gateway. Now, after creating, it will ask us to follow the internet gateway was created. You can now attach to VPC to enable VPC communicate with the internet. It means you have to attach your internet gateway to the VPC from which you have launched your instance subnets. Here I will select VPC1, attach internet gateway. Okay. Now, after creating internet gateway, I'll have to give the path to my subnets for the VPC. I'll create a route table, custom route table, as I will be able to delete it if I need it. I will be creating the route table 1. The VPC for which I want to create the VPC1, create route table, and here we will select the subnet association. Which subnet we want to connect to the internet. So we will select this from here, public subnet, save association. After that, routes, edit routes. Here we will add our internet gateway, that will add route. We'll put it anywhere, that is 0.0.0.0/0. It means we can connect it from anywhere, and here we will select internet gateway and select the internet gateway we have created and save the changes. After saving the changes, I will again go to EC2 instance connect and just refresh it. You can see now my VPC instance, custom VPC instance, is now get connected with the internet after creating internet gateway and giving it a proper route from the route table. Okay. Now I will create a subnet again. I'll create a subnet again. In VPC1. Now this subnet will be private subnet. So I am giving the name private. Private subnet. Okay. The availability zone, I'm giving the same 1A, doesn't matter. VPC CIDR 10.0.1.0/24. If I'm giving the same, it will show the error that CIDR address overlap with the existing CIDR. So I will have to be sure that I am not repeating any kind of CIDR's range, the existing. So I will put 2 for here and create subnet. Okay. So as I'm having a different subnet now, so I will create a different route table for that subnet. That will be route table 2 for private. Selecting the VPC, create route table. Here I am just associating my subnet with the instance that is my private subnet. Okay. I'm not giving any kind of internet connectivity over here, internet gateway over here. Okay. So in internet gateway is a route table. We have route table 1. Now I have created a public private subnet. I will again go to EC2 instance. I will launch instance again. That will be private. Here I will choose the key again, the same key. I'm allowing the ports HTTP and HTTPS. And edit the VPC, which we have created the custom VPC. And here he is asking for the subnets which you want to create. I want to create in public subnets. I will select private subnet. So I will select the private subnet, and auto assign public IP will be disabled. From the time it's creating, you will see how internet gateway statement says. What internet gateway statement says? An internet gateway is a virtual router that connects a VPC to internet. Default VPC is ready to attach with an internet gateway. If you create a new VPC, then you must attach the internet gateway in order to access the internet. Ensure that your subnet route table points to the internet gateway. It performs NAT between your private and public internet IPv4 addresses. It supports both IPv4 and IPv6 addresses. The NAT gateway is the another topic we'll be looking forward. First of all, we will see that how our internet gateway created or not, and we will check does it have the public IP address or not to connect to the internet. So there is a 2x2 check class in our EC2 instance for private. Here we can see we have our CIDR 10.0.2.215, but we don't have any public IP address. Okay, so this is our private EC2 instance. If you want to connect this instance, it will show the warning that the instance does not have a public IP address to connect browser and base client. The instance must have public IPv4 address. So that's why while creating the instances, you must have to ensure about what kind of instance you are creating, what kind of IPs will be given over there. Okay. Now I am going to terminate these instances to move further in the topic. Is we have done with introduction to network switches and virtual private cloud, VPC and subnets, internet gateways, understanding AWS security groups. Security groups are left. So we will now terminate these instances and create some of the security groups, create some of the instances using security groups with different connections. So I'm just terminating this and we will connect instances public and private with the help of using public subnets. So I'm not much longer needed for this Amazon Linux instances. I'll be showing it to you on Amazon Windows, Microsoft Windows instances. At the time, we'll look into for the NAT gateway and security groups. So security groups is nothing. It is a virtual firewall works on EN level, EN1 level. Up to 5 security groups per instance interface can be applied. It means 5 level of firewall ports you can enable on your instance at a time. It can only have permit rules, cannot have deny rules. Stateful return traffic of allowed inbound traffic is allowed, even if there are no rules to allow it. Here we can see now the internet gateway, NAT gateway. We have seen the internet gateway where you can connect your public instance to internet, but you cannot connect your private instance to internet because you don't have any kind of public IP on that instance and not even have the internet gateway. So how you can connect your private instance to internet with the help of public instance will be creating further. So first of all, we will read about NAT gateway and difference between internet gateway and NAT gateway. So NAT gateway is nothing but a network address translation. You can use network address translation gateway to enable instances in private subnet, connect to the internet or other AWS services, but prevent the internet from initiating a connection with those instances. You can change your creating and using a NAT gateway in your account. NAT gateway early usage and data processing rates apply. Amazon EC2 charges for the data transfer also apply. NAT gateway is a data chargeable service, cost service. So till the time you are using it, it will charge you for that service and also for the data you will transfer. Create a NAT gateway, you must specify the public subnet in which the NAT gateway should reside. You must also specify an elastic IP address associated with the NAT gateway when it created. No need to assign public IP address to your private instances. After you have created a NAT gateway, you must update the route table associated with one or more of your private subnet to point internet bound traffic to the NAT gateway. This enables instance in your private subnet to communicate with the internet. Creating a NAT gateway, this associate an elastic IP address but does not release the address from your phone. Here is the difference between internet gateway and NAT gateway. Just go through it. Okay. Looking into internet gateway and NAT gateway. Internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between VPC and the internet. NAT gateway is managed network address translation service. Internet gateway enables the resource like EC2 instance in public subnets to connect to internet. Similarly, resources on the internet can initiate a connection to sources in your subnet using the port. If a NAT gateway does something similar to internet gateway, but it only works one way. Instances in private subnet can connect to services outside your VPC, but external services cannot initiate a connection with those instances. In internet gateway, if a VPC does not have an internet gateway, then the resources in VPC cannot be accessed from the internet, which is unless the traffic flows in corporate network. In NAT gateway, NAT gateways are supported for IPv4 and IPv6 traffic. In internet gateway, it supports IPv4 and IPv6 traffic. Both support the IPv4 and IPv6 traffic. Internet gateway does not cause any availability risk or bandwidth constraints on your network, but in NAT gateway, each NAT gateway is created in specific availability zone and implemented with the redundancy that time. NAT gateway supports the flowing protocol that is TCP, UDP, and ICM. In order to make subnet public, add a route to your subnet route table and directs internet bound traffic to the internet gateway. In NAT, if you have resources in multiple availability zone and they are shared with one NAT gateway, and if the NAT gateway availability zone is down, resources in other availability zones lose internet access. Internet gateway, you can associate exactly one internet gateway with one VPC. Internet gateway is not availability zone specified. There is no additional charge for having an internet gateway in your account. In NAT gateway, to create availability zone independent architecture, create a NAT gateway in each availability zone. You can associate exactly one elastic IP address with the public NAT gateway. You can charge for you are charged for each hour that your NAT gateway is available and each gigabyte of data that is processed. So this is the basic difference, basic and all difference between internet gateway and NAT gateway. we have seen here. So now we will be creating instances using the VPC and create NAT gateway connection. So coming on the console, as we have terminated all these instances, right now we have 0 running instances. Okay. This time I will be launching Microsoft Windows instances. That is my public server first, which will be having a public IP. I will be using Windows instances. Here I will create a key pair for my Windows instance, that is RSA. The key pair name can be Windows NAT .pm. Create key pair. Here I will allow the HTTP and HTTPS traffic. I will edit the VPC and select the created one, custom VPC, and subnet will be public subnet, which will be enabled the public IP. Create a security group and launch the instance. We'll wait for running instances. As it is pending and status is scanning. So we can see now the running instances. Initializing, we have 2x2 check pass. Here, right now we have created a Windows server instance. We have created this. I have created this to show you how to connect a private instance with the help of public instance. As we have seen before, a private instance cannot get connected as it does not have public IP. This time also our private instance will not have public IP. Still, we will be able to connect it with the public help of public instance. So I have just created the public instance. Now I will create private instance also. I will select all the same data. In network setting, I will select our VPC 1, and in subnet I will select private set. Okay. Here, my auto assign public IP will be disabled. I will launch the instance. Waiting for our private servers 2x2 statistic. Okay. Now we are good to go for connecting our instances. So connect to Windows instance. First of all, we look for its public IP address. Yes, it is present over here, that 13.3, 13.61.1.6. So I'll connect this. Here we have three options to do. Session manager, RDP client, EC2 serial console. So we will be connecting this with the help of RDP client, that is the remote desktop client. Okay. To use the remote desktop client, first you have to download the remote desktop file of this instance. Connect with this using RDP. I have first downloaded the public server RDP. Each Windows public or private servers have their different remote desktop files. I am having public server RDP. Now, while using this public server RDP, I'll need a password to connect. So I'll get password and select my key pair which I have created at the time of making of my instance. So I will upload the private key file, that is windows nat.pf, and open it. So it is some kind of, it's in encrypted form. I will decrypt it. Decrypt. After decrypting, I have password for that instance. That is something like this. And I will copy the password and put it into the remote desktop file I have downloaded before. Here we will connect it. Password over here. Okay. Yes. You can see there is a blue line on the desktop showing that I am connected to the instance, Windows instance. Yes, okay. Here you can see there is a host name, instance ID from which instance you have launched, private IP of that instance. That is the range of CIDR we have given manually. Then the public IP address, instance size that is T2 micro, will be the zone where it is made, IP South 1A. Architecture of the kernel, total memory that is 1024. This memory is nothing but the RAM of your CPU kernel, which we have selected from the AMI, and the network low to moderate. Okay. Here, when we open our command prompt to connecting the instance, we can check that our system IP, which instance IP which we have connected, is pinging and giving the output. Okay. So just like this, we have to connect our private instance. Okay. So we'll try to connect the private instance. Go to our instances. Select our private server instance and connect it using the RD. We'll download the remote desktop file and get the password for this instance also by selecting the key pair we have used for creating the instance. This is also in encrypted format, so we will decrypt it. And copy the password, paste it into the Windows remote desktop file server after connecting it. You can see that remote desktop can't connect to the remote computer for one of this reason. Why? The remote access has not enabled or turned off or not on the network. So this our private instance doesn't have the public IP. That's why it is not able to connect using the RDP or any kind of miner. So what I will do, I will just go to my public instance which I have connected by copying the password for this private instance. I'm in my public instance console. Here I will use Windows R. Windows R. Just a minute, there is a blockage in sharing. Just a minute. Just sharing the content once again. We have some. Okay. I think you can see my console now. Okay. Now I'll connect it to the share to the remote desktop from where I'm going to use the RDP file. So here I'll be using Windows R and run command RDP. Okay. It's not connecting, so I will search for my RDP over here. Remote desktop connection. So I will just select it. Here you just have to put the IP, that is the public IP of the your private IP of your private instance. That is 10.0.2.207. 10.0.2.7. We will connect this. So it will ask for credentials. We have to put the credential, that is username, administrator, and the password which we have copied before. Here it's showing an error that you cannot, the credentials here used to connect did not work. These new credentials. Okay. So I will just check my credentials again. Copy it, then paste it again. Password also. Now we are connected. Okay. Now you can see that I have connected my private instance with the help of public instance using the RDP connection. But here, as I have done previously in my public instance, I have checked my ping for the connection. I will check it here also. So same here. Bazaar, CMD. Okay. What I will have to do, just ping my connection. So it's not showing any kind of data of pinging of connectivity. It's a request timeout because we don't have the internet the connection in our private instance. So we'll have to manage a private instance with connection. So first, we'll have to again go to. So now we have to go to again in our VPC console. Here, in the bottom of virtual private gateway connection above the security, there is a NAT gateway. We have to create NAT gateway. For that, we'll select the option at the right upper corner that is a create NAT gateway. We'll put some name over here. Gateway. For the subnet. Now, I want this NAT gateway for my private subnet, but at the time of creation, I will have to put it on my public subnet because I'm connecting my instance from my public subnet. Okay, and allocate the elastic IP for the connection and create NAT gateway. As NAT gateway get created in route tables, where the routes of our subnets on which our instances has made, I will be giving the NAT gateway to my private subnet. At the time of creation of NAT gateway, I have created it on public subnet, but at the time of applying it to route table, I am applying it to private subnet. Routes, edit routes of private subnet. I will add route and pairing net connection. Sorry, NAT connection. Select. I will change this. Okay. Now I have given all the necessary connections and routes to my instances. Now I'll check pinging action again. It will take some time to enforce. Now you can see the reply is coming again. Like this, we can go connect our private subnet instance with internet or bring it with the servers by using public subnets, public instance. I'll close this. Connection. As I'm not in need of better instances. Terminate the instances before deleting this. Before deleting VPC, you have to terminate the instances as it is created on your VPC. So it won't get deleted if till the time you did not terminate your instances. Get it terminated. Now, to go to VPC. First, I will have to remove this NAT connection for deletion. The question for today's topic. as it get deleted, go to VPC and select our all the things we have created till now for creating our customized VPC can get deleted from here. All the things we have attached with that VPC, that is internet gateway, public subnet, private subnet, route table 1, route table 2, will get deleted if there is not any kind of external connection we have attached. We'll just type the command and it will get deleted at once. Now you can see that we are back to the same basic stage where all the things are as same as before we have created. Only the security groups is added as the main, because when you create instances, every time you create a new security group. If you are using the existing one, security group will not create again and again. The question regarding the topic. So today, from the starting of the session, we have created the today's topic introduction to network switches and virtual private cloud, VPC and subnets, internet gateways, understanding the AWS security groups, and launching our first EC2 instance in custom VPC. In previously given VPC, we have already connected in 2 times. Custom VPC, we have created the Microsoft Windows instances and use the NAT connection also connected. I'm having some more data to share with you other than the topics given. This peering connection. Peering connection is nothing but connecting the VPCs of different accounts, different region. This peering connection helps you to create a connection between the different regions. Like I have created the VPC in Mumbai region and same region I have created the instances in their given availability zone. But with the help of VPC peering, you can create VPC peering connection in two different regions, and then you can connect it by using these some of the steps. After that, we have virtual private network. That is, we can say VPN. To stand for virtual private network, it refers to the safe and encrypted network that allows you to. Using VPN, you can create a safe connection over a less secure network, example, internet. It is a secure network and this is completely isolated from the rest of the internet. The government, businesses, military can use this network to use network resources. VPN is free to use and it is used site to site and remote access methods to work. It uses an arrangement of encryption service to establish a secure connection. It is an ideal tool for encryption. What does the actually VPN do? It just VPN works by creating a secret tunnel using powerful VPN protocols. It hides your IP addresses behind its own IP address and encrypts all your communication. This thus your communication passes through a secure tunnel that allows you to use network resource freely and securely. There's one thing left over here in VPC. We have given the elastic IP and we didn't release it till now. So I will just select that elastic IP and in actions, I will release that elastic IP. As reserving the elastic IP can cause the expense, cause the amount charges in your account. there any question again? Say again. So I'm considering the no response from the other side. So I'm considering that everything everyone has understood the topic given and the extra things I have told about the UPC connections.
Prasanna, can we finish? Prasanna.
Yes, sir.
Do we have anything to discuss? Hello?
No, sir. I don't want to discuss anything. We have finished it very much time ago, and I have told the extra things, whatever I can say about all these VPC topics.
So do you need some more class or should I announce it?
No, sir. It's fine for today's 11:12.
Okay.
Okay.
Yes, yes. So now I'm okay, dear participants, if you are having any queries, you can ask it now.
I have raised the question. Is there any question regarding the topic? But no one has asked. It's been while more than 20 minutes.
Okay. Okay, so can we finish it now?
Yes, sir.
Okay. So dear participants, please fill the feedback form of session and we are closing down this session over there now. Feedback form link is available in the official WhatsApp group. Thank you, Prasanna.
Thank you, sir. Thank you all the participants.
Next session will start sharp at 2 p.m.